Alright, we'll talk about increasing and decreasing, and how to find out when a function, without looking at the graph, how to find out when a function is increasing or decreasing. So the information for that is always going to come from the first derivative. Well, it could come two ways, I guess. Yeah, we're just going to say that to make it simpler. It comes from the derivative. So remember, derivative tells you slope. So if f prime of x is greater than 0, or positive, slope is positive. If the derivative is less than 0, which is negative, your slope is negative. So the derivative just tells you, here's what the slope is. And if it comes out to be a positive number, then the derivative is positive. If it comes out to be a negative number, then the derivative is negative. And then where it changes from positive to negative, we're going to call those max and mins, but we'll get to that probably tomorrow. So let's show you the process, and you're going to use this process a heck of a lot over the next month or so. Say I gave you x squared minus 2x, and I said find where the function is increasing and decreasing. So I'm going to show you the graph. You don't need to know the graph, but I want you to be able to look at what you're finding. So it would look like this. It would have intercepts at 0 and 2, and the minimum would be there. So the graph should be decreasing up until you get to x equals 1, and then increasing after that. And so how can we get that algebraically? Well, what we're going to do is take the derivative. So increasing, decreasing information comes from the derivative because the derivative tells you slope. I'm going to set that equal to 0. And what I'm doing there is finding critical points. So you set the top and bottom of the derivative equal to 0. Now in this case there is no bottom, so we don't have to worry about it. We're just setting the top equal to 0. But what you're doing there is finding the spots where the graph is either flat, or if the bottom equals 0, it's vertical. And that's the spots where the graph is either going to switch from going up to down or down to up. So if we solve this, we get that x equals 1. What that means that x equals 1, we got a slope of 0. But remember, we can't really see the graph in this problem. What that does is take kind of a number line. Imagine a number line, and it splits your graph into two parts. If I had 2 solutions for x, it would split my graph into 3 parts. If I had 3 solutions, it would split it into 4. So you got these 2 parts. You're going to label them. This part is negative infinity to 1. This part is 1 to infinity. You do not get any credit for the number line on the AP test. You get credit for writing this. And if the number line helps you, by all means, write it. Now what we're going to do is take a point between these 2 points. So some point in between, any x value in between negative infinity and 1. And you're going to plug. So plug points from each interval into y prime. Because what does y prime tell you? It tells you slope. So I'm going to take 0, because 0 is the easiest point I can think of between negative infinity and 1. So if I plug 0 into the derivative, I get negative 2. I don't care what the number is. I just care that it's negative. That means f prime of x is negative, which means f of x is decreasing. It's important to write on both of those. It's important to understand they are the same thing. They're just written different ways. This means our derivative is negative. That tells us we have a negative slope. This means the original graph is going down. That also tells us we have a negative slope. They do mean the same thing. They're just, you need to write them both ways. So this is true all the way from negative infinity to 1. So that's part of your answer. Where's the graph decreasing? Right there, negative infinity to 1. Repeat that over here. Pick a number between 1 and infinity. Let's say 10. 2 times 10 minus 2 is 18. I don't really care what the number is, just whether it's positive or negative. That means my derivative is positive, which means my original graph is increasing from 1 to infinity. And that's all I'm looking for today. Can you tell me where the graph is decreasing or where the graph is increasing? We knew that. We knew looking at the graph it was decreasing all the way up to 1 and increasing after. If you split it like this, it's decreasing on this side and increasing on this side. I'm just showing you how to get to it with the calculus and algebraically. Alright, let's say y equals 1/3 x to the third minus x squared over 2 minus 6x plus 8. Some of you, I think, are better at this than others. I'm going to rewrite the original equation first and just pull that like 1/2 out. And I didn't take a derivative, I didn't do anything there, I just rewrote this second thing. Now if I take the derivative, I'll get x squared minus x minus 6. I set the top and bottom equal to 0. There's no bottom, so I don't have to do that, I'm just setting the top. I'm going to factor it. This will be x minus 3x plus 2, which would give me x equals 3 and x equals negative 2. And again, if you imagine a number line, that splits your graph into 3 parts. 1 part from negative infinity to negative 2, 1 part from negative 2 to 3, 1 part from 3 to infinity. Again, the number line does not get you credit, but if it helps you get to this step, then do it. And then we're going to pick a point from each interval and plug into the derivative. Now, when I say plug into the derivative, you got choices. You can plug in there, or you can plug in there. And it might be different in certain situations than what you're plugging in. So, for example, if I'm plugging in negative 10, I don't really want to deal with plugging the negative 10 in there and squaring it, and I might screw up the sign. What I'm going to do is plug negative 10 in there. Negative 10 would make this term negative 13 to be specific, but I just care that it's negative. Negative 10 for x would also make this term negative. So negative times a negative is a positive. So f prime of x is positive, which means f of x is increasing. Say I plug in 0. If I put 0 there, this is negative. 0 there, this is positive. Negative times a positive is a negative. So your derivative is negative, which means f of x is decreasing. And then plug in like 20. 20 would make that a positive and positive, that positive, so your derivative is positive. And f of x is increasing. And this is what I want at the end. I want to be able to say it's increasing from there to there, it's decreasing from there to there, it's increasing from there to there. And that's it. So there's a short worksheet with 5 problems on there and the answers. So please have that done for tomorrow, and we will keep going.